Hello learners, today we are starting our new topics differentiation and its application. We already know about the limit function. Now our in advanced mathematical these chapters yani differentiation it's start from our limit concept. You know that in our limit concept is a process of finding a value of a function at a given point. Now in these chapters we want to definition of differentiation and some its rules of sum, product, quotient, chain rule, derivatives of implicit function, derivatives of parametric function, and successive derivatives. Now we find second, third derivatives. And last of this chapter, end of this chapter, now we apply our concept of derivatives to finding velocity, acceleration, maxima and minima. Now actually differentiation and our next upcoming concept integration, we can solve real world problem like maxima, minima, rate of change, amount of materials, building, profit, loss. Differentiations is now it is finding rate of change. You know that velocity, there are two quotient of difference of distance and difference of time. It is also a rate of change. You know that at a time the coronavirus, many times we hear the rate of change of metabolic of the corona is something. Now it is a rate of change. Now I say that derivatives is actually finding a limit. Suppose we denote derivatives to f dash x. That's f dash x is nothing but limit of x tends to 0 functions at fx plus h minus fx upon h. That is actually a rate of 2 points. It is a derivatives. Now let us start this chapter with some simple formula. For example, now derivatives of constant functions is a 0. Similarly, the derivatives of x is 1. Derivatives of power of x is equal to n times x raised to n minus 1. Derivatives of cos is minus sine. Derivatives of sine is cos x. Derivatives of tan x is sec square x. Derivatives of cos x is minus. Derivatives of cos x is minus sine x. Derivatives of cot x is minus cosec square x. Similarly, derivatives of log x is this. Something like such a function derivatives we are given by the standards formula. Now using this formula, now we start our concept. Now we define some working rules and its examples. First working rules of derivatives. It is working rules of constant function. Now I want to say derivatives of constants is a zero, यानी कि f is a constant function, its derivatives we consider always be zero. For example, fx is 100. Now f is constant function, so its derivatives is f dash x is 0. Now another example, if fx is equal to sine 45, it's clearly you know that the sine 45 is 1 upon root 2. So f is the constant, its derivatives is 0. Now second working rule. Second working rule is derivatives of power. In generally polynomials we define its in power of term of its variable. Suppose fx is equal to x raised to 5. Suppose fx is equal to x raised to 7. Thus we have a power of variable. Now in working rules we want to say derivatives of power is nothing but the power time derivatives of variable 1 is less, यानी कि if fx is equal to x raised to n, we have f dash x is equal to n time x raised to n minus 1. Now consider example. If fx is equal to x work, we have formula f dash x is equal to r time x r minus 1. Now fx is equal to x work, we have f dash x is equal to 2 times x. Similarly, fx is equal to x raised to 5, we have using this formula, we can find its derivatives 5 times x raised to 4. Now derivatives of sum, यानी कि sum derivatives of sum is nothing but the sum of the derivatives. Now it is clear, if f is the sum of the two functions, say f is equal to fx is equal to gx plus hx. Here hx and gx are also function of f. Now derivatives of f is nothing but derivatives of g plus derivatives of s. यानी कि derivatives of sum is the sum of the derivatives. Now it is clear that derivatives of sum of the function. Now using this concept, now we solve two examples of these rules. Suppose fx is equal to x work plus 4. Here fx is sum of the two functions. Say our gx is equal to x work, hx is equal to 4. Now again gx is the power of a variable. Thus using this formula, derivatives of gx become 2x and h is the constant, its derivatives is 0. Thus we apply in the derivatives of sum law, we have received totally derivatives is 2x. Similarly, if fx is the sum of the two functions x raised to 5 plus 4, apply our this addition sum law of derivatives, we can receive its derivatives 5x raised to 4. Now our next working rules, derivatives of difference functions. Derivatives of the difference function is the same as the derivatives of the sum of the functions. Now if fx is the difference of two functions, if fx is equal to hx minus fx, then we have derivatives of fx is g dash minus h dash. यानी कि derivatives of the difference is difference of derivatives. Now we clear these rules by a suitable example. If suppose we have fx is equal to x raised to 3 minus x raised to minus 2. Now here clear that f is a difference of two functions g, यानी x raised to cube hx यानी x raised to minus 2. Both are the power of functions of variable. The derivatives of gx is clear, 3x square. Also derivatives of hx is clear, minus 2 into x raised to minus 3. Apply the difference of the derivatives law. We have the received f dash x is nothing but 3x square plus 2x minus 3. Now our next working rules of products. If suppose many times given the functions in terms of the product of two functions, in this case we have derivatives of product of two functions. If fx is equal to fx is sum multiple of two functions hx and gx. In this case the derivatives we take is simultaneously. F dash x is equal to keeping one function is constant, another is derivatives plus another is derivatives, keeping function is derivatives. In symbolically, f dash x is equal to gx into h dash x plus hx into j dash x. यानी कि we take derivatives of first function, remaining its constants simultaneously. Consider this law by the simple example. If fx is equal to multiple of polynomials x square minus 5 into another polynomials x cube minus 2x plus 3. You know that f is clearly multiple of two functions. Let first say f is multiple of u and v, where u is nothing but x square minus 5 and v is nothing but x square minus 2x plus 3. Now derivatives of u is 2x and also derivatives of v is 3x square minus 2. Applying the multiple law, you have finally received derivatives of f is a derivatives of u into v plus derivatives of v into derivatives of u plus v. Any key finally answer is 5x raised to 4 minus 21x square plus 6x plus 10. Now next working rule, our derivatives of quotient of two functions. If many times suppose f is in term of gx upon hx, gx is also a function, hx is also a function. Thus the derivatives of quotient of two functions is nothing but the suppose fx is equal to gx upon hx, then we have f dash is equal to hx into g dash x minus gx into h dash x upon hx whole square. यानी कि we can do derivatives of the quotient function by this formula. Consider two example of this. Suppose fx is equal to x minus 2 upon x plus 2. Here hx is equal to x minus 2 and gx is equal to x plus 1. Gx and hx we are given. Substitute in derivatives of quotient rule, we can finally get its derivatives 3 upon x plus 1 whole square. Now we complete our these working rules. Now we are going to some special methods of derivatives. Consider our composite function. Composite function is nothing but the combination of the two or more than functions. A composition word is coming from the words of music. Many times we hear that this saying the composed by the Rahman. This composition means there are the two different functions. We add the mix of this. Suppose in this concept we already know about in our limit and function chapters. Suppose f is the compositions of h, g and h function. यानी कि fx is equal to g compose h. Then in this case we have derivatives f dash is equal to derivatives of g compose h into derivatives of h. Consider this rule by the simple two examples. If fx is equal to sine log x, here clearly there are fx is the compositions of two functions. First is sin x, h is hx. Let g is sin x, h is the log x. Now the derivatives of g dash is equal to cos x, the derivatives of h is equal to 1 upon x. Now derivatives of g dash compose hx is equal to cos log x. Applying this rule, we can find is the final derivatives cos log x into 1 upon x. Also you can find another composite functions its derivatives. fx is equal to sine composite with cos x. And by applying these rules, you can find its final answer is minus cos x into cos x. Now, these chapters, our concept, introduction, working rules, working rules example, and the derivatives of the concept rules. Now we are going to the closing this first part of the derivatives. Now our keeping in mind our milestone of this chapter, you have to the complete what is the next and testimonial, and the next is our part derivatives of part 2. In next part we meet by another custom. Good luck. I hope this, if you clear this first part, now we meet in our second part. Thank you every learner, and thank you everyone.